In this video, I'm going to walk through how to factor quadratic trinomials that have a leading coefficient that isn't equal to 1. First, always, look to see if there's a GCF and factor that out. The first step then after doing that is to look for two numbers that multiply to A times C and add up to B. Once you find those two numbers, we're going to write fractions. The two numbers you found in step 1 will be the numerators, and the leading coefficient A will be the denominator. Next, simplify those fractions if they can be simplified. Sometimes they can both be simplified, sometimes just one of them. Now comes the part that makes us call this the bottoms-up method. In the bottoms-up method, we're going to take the two fractions that we found and simplified, and we're going to take the bottom of each of those two fractions, and we are going to put those first as the leading coefficients in the binomial factors that we create. And then the numerators will become the second constant terms in the two factors that we create. I'll set these steps aside, and then I will go through a few examples to show you how to do this. Starting with 3x squared plus x minus 2. There's no GCF, so we'll look for two numbers that multiply to the product of 3 and negative 2, negative 6, and 1, 3 and negative 2. Now we take that 3 and negative 2, and we rewrite them as fractions over a, which is 3. Then we simplify these fractions. 3 over 3 reduces to 1 over 1. Negative 2 over 3 doesn't. Now we do the bottoms up. We take those denominators and we put them first. 1 you don't have to write. And then we put 3x minus 2. So x plus 1 and 3x minus 2. Now let's do another example using bigger numbers. Here we have 8x squared plus 38x plus 35. I'll multiply a times c. So 8 times 35, oh boy, mental math time. 8 times 30 is 240. 8 times 5 is 40, so 280. Now they have to add up to this coefficient here, so they have to add up to 38. All three terms in this case are positive, so we're looking for two numbers that multiply to 280 and add up to 38. The thing with big numbers like 280 is that nobody really knows all the factors of that off the top of their head. But we can think of some by looking at how we got that 280 in the first place. We got it from 8, which is 2 times 2 times 2, and from 35, which is 5 times 7. So if 2, 2, 2, 5, and 7 are the prime factors that build 280, then all of the factors can be built from different combinations of 2, 2, 2, 5, and 7, with the exception of 1 and 280, but that would add up to 281, and 38's not even close. We also know that 8 times 35 won't work because 8 plus 35 is equal to 43. But that's really useful information because 43 is really close to 38. The other thing that's going to help us is knowing that because 38 is even, we either have to have both numbers being odd or both numbers being even. So what number is close to 8 that can be built from these prime factors? 10, All right, so 10 times what is 280? 28. Now let's check to see if that adds up. 10 plus 28 is equal to 38. And, oh, first try I already got it. Our two numbers, therefore, are 10 and 28. And now let's write our fractions. Our leading coefficient, going back, is 8. So we'll write 10 over 8 and 28 over 8. Simplifying them both, we get 5 over 4, and take 4 out here, 7 over 2. And then bottoms up to write our final trinomials. So 4x plus, because everything's positive, plus 5 is one factor, and 2x plus 7 is the other factor. Let's pull up another example. Negative 6x squared plus 14x minus 4. First step, always look for a GCF. And in this case, my leading coefficient is negative. And, this is kind of a personal preference, but honestly, let's get rid of that negative as long as we have to factor out a GCF. So let's factor out negative 2 instead of just factoring out 2. Dividing each term by negative 2 will give us 3x squared minus 7x plus 2. So we just ignored this negative 2 until we're done with all of this. So now our a is 3, b is negative 7, c is 2. A times c is 6, b is negative 7. And whenever b has a bigger absolute value than the product of a and c, then it's probably because the two factors are going to be the product of AC and 1. Now we have a minus plus situation, so both our factors are negative. So we're looking at negative 6 and negative 1. Negative 6 times negative 1 is positive 6. Negative 6 plus negative 1 is negative 7. Writing the fractions now, we go and we put it over this a, not the a from the original problem. So we put those numbers both over 3. Simplify. Negative 2 over 1. And yeah, you do want to keep this 1 in the denominator till we're done. And now go bottoms up. So 1x minus 2, which is just x minus 2. And 3x minus 1. Don't forget that negative 2 from the beginning of the problem. I'll add 1 or 2 more examples here. All right, so let's do this 12x squared plus 7xy minus 12y squared. So when we have a trinomial that's ax squared plus bxy minus cy squared, we use the same techniques. Just know that your final factors will look like this. They'll have x's in the first terms and y's in the second terms. So we're looking for two numbers that multiply to a times c, which is 12 times negative 12, so negative 144, and also add up to the coefficient b, which is 7. So in this case, we have a negative product and a positive sum. So we're looking for one positive and one negative number. The larger absolute value number, the bigger number of the two will be positive, and the smaller number will be negative. And they're 7 units apart. So they don't add up to 7, they're 7 apart. Two numbers that multiply to 144 that are 7 apart. The biggest clue to help us with this one is the fact that 7 is an odd number, and that only happens when one of the factors is even and one of them is odd. And 144 has a ton of even factors, so that makes the choosing easier because there are only so many odd ones. So possible odd factors of 144 would be 3, 9. Gee, I think everything else is a power of 2. 3 goes into 144 48 times, and that's definitely not 7 apart. 9 goes into 144 16 times. 16 minus 9 is 7, so there's our combination. But remember, the bigger one's going to be positive, smaller one's going to be negative. So our two numbers will be negative 9 and positive 16. A was 12. So 12 becomes our denominator. We simplify. 3 goes into this one. 4 goes into the other one. Slide this up, get some stuff out of the way. And now we finish by going bottoms up. So the denominators go first. 4x minus 3y, remember for the y's from above, and 3x plus 4y. Let's do 2 more examples before we wrap up the video. So let's look at this problem, negative 3x squared plus x plus 2. It looks similar to one that we did earlier, but this one has that negative leading coefficient. So while there's no GCF, I'm still going to factor out a negative 1 because I like my leading coefficients to be positive. So I factor out the negative 1 from every term, and now I'll just ignore this negative 1 till the end. Okay, so my A is 3, my C is negative 2, so AC is equal to negative 6, and B is equal to negative 1. So I have a negative product and a negative B, so I'm looking for 2 numbers of opposite signs, but the larger of the 2 numbers is going to take the negative sign. So 2 factors of 6 with a difference of 1, 2 and 3. 3 is the bigger one, so 3 will be negative, 2 will be positive. Now we put those over A, then simplify, and then go bottoms up. X minus 1 and 3x plus 2. And don't forget that negative 1 we took out earlier is a factor that has to be included in our final factored expression. Okay, now one last problem so we can get some practice with the bigger numbers. First, make sure there's no GCF. There isn't between 332 and 20, and there's no GCF within the variables. It's all plus, so we're looking for nothing but positive numbers. 2 numbers that multiply to A times C, which is 3 times 20, which is 60. And they have to add up to 32. So looking for clues. B at 32 is a big number in comparison to 60. So it's likely that the 2 numbers are going to be further apart. because the farther apart the numbers, the greater b will be, even when those numbers aren't going in opposite directions, if the numbers don't have opposite signs. So I'll just start at the beginning of the list of factors. 1 and 60, well, that would be 61, so that won't work. 2 and 30, well, there you go. They add up to 32. So those are my two numbers. My a is 3, so I write fractions 2 over 3 and 30 over 3. Simplify them. This one's already simplified, so this one is 10 over 1. So finally we go bottoms up with this problem. The 3 comes to the front, 3x plus 2. Everything's positive in this problem. And our other factor will be 1x, which is just x from the 1 in the denominator, plus 10. That's enough examples. Let's just go and recap the steps really quick. For factoring trinomials that have the form ax squared plus bx plus c, in other words, this leading coefficient is something other than 1, the steps are, first, before you do anything else with any type of factoring, you look for GCF. Then, look for two numbers that multiply to the product of a and c, and that add up to the middle coefficient b. Next, put those two numbers in fractions and make the leading coefficient the denominator. Simplify the fractions, and then finally go bottoms up, which means take those fractions, make the denominators go first in your binomial factors. And don't forget, if you do take out a GCF, you ignore it till you get to the very end, but don't forget to stick it on the front at the very end. That's the bottoms up method for factoring. There are, of course, other methods. This is the one that I prefer to use, but if you have something else that works for you, then by all means stick with it. But if you're not getting consistent results, I suggest trying this one or another method similar to it.